of Opacity or the deconstructive reading of software engineering, So when I read it, I say, well, these stages, these ideal stages of knowing what you want to do and then knowing how you want to do it and then planning how to do it and then doing it, conceptually have a meaning. But in reality, they become undone, as the construction says all the time. So these boundaries between stages are transgressed all the time because you go back and forth, you don't go just, in one direction and so on. So if you take this to the extreme, you realize that actually the way the software develops is by going wrong or by generating unforeseen consequences. We like to have this linear conception of time, and iteration is kind of seen as the exception when in fact it's the norm. And the result of that is that we never know perfectly what our technology, what we want our technology to do. We think we do. We think we know what it wants to do, what we want it to do. And then we start developing it because we have to start at some point, even if we haven't, if we are unaware of the parts that we don't know. These are unknown unknowns, sort of. Your ignorance of what your technology is supposed to do or supposed to be is constitutive of the very process of creating it. So you start without knowing exactly everything. And that's okay. Technology and philosophy became opposed. And as we know from deconstruction, when there is a binary, there is very often a term that is valued and a term that is undervalued. So in that sense, episteme, knowledge, philosophy, is what, is concerned with the truth, with finding the truth. It's a noble enterprise, while techne is simply the using of instruments. Techne is simply something that exists to be used by others, and it has no interest in finding the truth. So this opposition was a political act that happened in Athens, and then devalued technical knowledge for centuries. That's why technology for Stigler is a problem for philosophers in the sense that, especially continental philosophy, but in general, philosophy is not prepared to think of techniques as something essential because it's not concerned with the truth. And his theory is exactly the opposite, that the techne is essential to the human, that it's not a tool, it's intrinsic to the human.
So, hello everyone, I'm Stefanos Baziotis. I'm a fourth-year PhD candidate at the Computer Science Department of UIUC. Welcome to the second episode of In the Midst of Philosophy podcast. And the goal of this podcast is to bring important figures from the fields of philosophy, technology, and science onto the foreground of public awareness. Today, we're joined by Federica Frabetti, Associate Professor in Digital Media at the University of Roehampton. And again, Federica, you should correct me if I say anything wrong.
Perfectly okay, and thank you for having me.
It's okay. So, correct me if I'm wrong with anything I say here. So, Associate Professor in Digital Media at the University of Roehampton, an author and a former software engineer with a background in British cultural studies. Federica has written the incredible book, Software Theory, a Cultural and Philosophical Study, which will be the focus of our discussion today. Now, I want to say here that I do have this book. It's a physical copy. I totally recommend it. And I should say, so actually, Federica, so I don't read ebooks, by the way, but is this available as an ebook?
Yeah, I think it should be. The publisher published both the hardback, paperback, and probably ebook. I don't know.
Okay.
You can check.
And because last time we had Bill and I didn't show his book, so this is Bill's book. And I have a bunch of other books here. So this was kind of my preparation for reading your book, right? So folks, if you're interested in this book, I totally also recommend these as a companion. I think we'll mention some of them during our discussion. In this book, in Software Theory, Federica draws upon the work of, I should say, underrated figures like Bernard Stiegler, Jacques Derrida, and Timothy Clark to enable a new cultural and political understanding of software. Before welcoming Federica, I'd like to inform the audience about my project for this discussion, which is a little bit different from that of the previous episode with William. In this episode, my goal is to introduce you to Federica's book and to shed light to some aspects of it that may be unfamiliar, to to people like me, frankly, who don't have much background in cultural studies. And then we hopefully will discuss more general topics still probably related to the book. So with that, let me welcome you, Federica, officially. And thanks for being here today. I'm really excited about this discussion.
Thank you for having me. I'm really excited too.
Nice. Okay. So I guess, we could start with some warm-up questions. Maybe you can tell us a little bit about your background and then maybe explain to people like me, what does it mean to have an expertise or to work on British cultural studies? What is that exactly?
Yeah, so British cultural studies is, well, a British field of studies. And I guess cultural studies in America, in the States, is also there as a discipline. But British cultural studies was born out of the work of thinkers who made it their job to decide and demonstrate that culture is not just highbrow culture, but also so-called lowbrow culture. So the take of cultural studies is that, okay, we know that Shakespeare is literature, but how about the working class culture? How about popular novels, magazines, you name it, the TV shows? These are also culture. So the field was born with a strong Marxist background, if you wish, if you're with a strong Marxist angle. Then it merged at some point, for some aspects, with the studies of media, with media studies. So in the book, I refer to media and cultural studies as one discipline because there are
In
so
fact,
many.
the book here says media philosophy, which I think is really cool. Yeah, I haven't seen the term media philosophy again.
Yeah, because that's, again, a part of the idea that tends to draw on philosophical work. I think it's just a cool title for a book series.
Okay.
What cultural studies is in Britain is definitely a quite developed field now, and it's an interdisciplinary field, and it gives it can give different privilege different angles. So, for example, you can find cultural studies that are more orientated towards the textual study of certain media products. You can find cultural studies that are focused more on the political economy, more on the sociological and empirical aspects. And so what I was trying to do when I started this research in the early 2000s, the first decade of the 2000s, was to bring cultural studies in dialogue with philosophy, because that was not so popular. It was more like an empirical field, if you want. And I thought that philosophy, and especially continental philosophy, had a lot to say to cultural studies for the understanding of cultural objects. And also the other thing to say is that, of course, culture at that point, in the general sense that cultural studies gives to the term culture, which is mainly an anthropological sense. So it's a way of life, meaning a way of life of people, right, in society at a certain point. So was becoming intensely digitized because we were dealing with, the internet, the web, but also social media was kind of becoming relevant. And so it was impossible to study the media and popular culture without actually studying digitality. And so there was a general awareness, a growing awareness. This book is very much of its time. Yeah, it came out at the end of 2014, but the research was done a little bit before. It talks about how software is an emergent object of study in media and cultural studies, because it had not been before.
I see. Okay. So I guess before we go to the actual book, maybe these are a little bit dumb questions, but just on the British cultural studies field. First of all, what is the British part? From what I gather from what you said is that the British part is mostly that it's done in Britain with a British tradition.
It started with the British tradition, and it's the kind of cultural studies I found when I moved to London to do a PhD.
I see.
I thought I would do media studies with a focus on digital media. And I bumped into this field, cultural studies, which, it had a British origin and a British angle. But it was not about the culture in Britain. It was about everything, really, and provided me with the means to study culture in general as a way of life and its digitized aspect as well. and it had overlaps with media studies. So that's why in the book I refer to media and cultural studies. It's really a broad field. Some studies are not, you're not sure if they should be categorized as media studies or cultural studies. It's just the study of culture as in not highbrow culture.
That's interesting. So actually on that, on the last thing on British cultural studies or cultural studies in general. So when you talk about media studies, what I'm thinking of is, well, hold on, I have it here. It's in this pile of books, Marshall McLuhan, Understanding Media. And that people tell me that it's the book that founded media studies. First of all, do you agree with that?
Yes, I mean, that's the point. Marshall McLuhan was very much a foundational figure of media studies. He's definitely considered a foundational figure. Maybe in the UK, well, that's quite interesting as something to say. In the UK, Raymond Williams and the tradition of cultural studies, the idea of studying the way people work with media, what people do with the media, was prevalent on Marshall McLuhan's views. So there were basically at the time two kind of strands. They're not clearly opposed to each other, but you can the one side, which was the mainstream media studies, scholars investigate what people do with media and what people do, for example, with the internet, given that we were, in the age of digital media. And so, how people produce and consume digital media. And that's very much the same as looking at cultural studies, it's the same perspective. McLuhan was considered slightly on the technologically deterministic side of the discipline. So, of course, Marshall McLuhan is a foundational figure. We studied it in Italy. Like in secondary school, I was told at some point about Marshall McLuhan. But Marshall McLuhan is the foundational person that makes it possible for media studies and digital media studies especially to look at the technological aspect of the media. This famous sentence that the medium is the message is telling. So McLuhan, in his theory of television, for example, and the radio, the kind of mass media he had at the time, he thought that, television, for example, doesn't just vehiculate a content. It doesn't just, give us the news or give us a show. It first and foremost vehiculates itself. So what do we watch when we watch television? Well, television as a medium, as a technology. So the technological aspect of media was very, very important for Marshall McLuhan. And he would be the scholar I refer to whenever I address the technological aspects of media.
Interesting. Okay, that's pretty cool. So before we get to, what I want to ask before we go to the actual book is maybe you can tell us a little bit about what continental philosophy is. Well, let me admit here that I mostly heard the term from you, and then I looked it up, and there doesn't seem to be any consensus. Some people define continental philosophy as the negation of analytic philosophy. But then the problem is you go to figure out what analytic philosophy is, and they tell you analytic philosophy is not continental philosophy. So there's this kind of circularity there. And it seems to be a catch-all term that is pretty much vague. And honestly, okay, I should stop talking here. But honestly, to me, it seemed more that people define it through some figures, like, I don't know, Derrida, for example, rather than the practice itself. So maybe you can enlighten us.
Well, what you call circularity, for me, is very interesting. But to be honest, again, I met this opposition, this kind of definition, when I started my studies in the UK. Because in Italy, for example, we just study philosophy, and it's not limited to analytical philosophy or continental philosophy. It's just philosophy. So what is continental philosophy? Well, I had a fantastic supervisor, I must say, when I was a PhD, Joanna Zileska. Maybe you want to interview her at some point. And she pointed that out to me. So I found out. But
you mean, sorry, excuse me, she pointed the difference?
She pointed out the difference, yes. And okay. So I looked at that, and you're right. Continental philosophy is an umbrella term for a variety of philosophical traditions that have a family resemblance, sort of, something in common. I would say, if you look at perhaps the difference between continental philosophy and what is called analytical philosophy. Continental philosophy is characterized by the attention to the historical context, the social context, the emphasis on experience. So, for example, philosophical schools like phenomenology, so Heidegger, Husserl, that privileges the way that people experience the world. Existentialism, so think of Jean-Paul Sartre, so the idea that what is the meaning of life, or is the life meaningless? Another part of continental philosophy is probably critical theory. So the part of critical thinking about the social, political, and economic structure of society that is typically done by the so-called Frankfurt School. So Adorno, Althusser, Marcuse, again with a strong Marxist foundation. And then, of course, structuralists and post-structuralists. So the French, for example, like Derrida and Deleuze are also part of continental philosophy. In opposition to what? Well, in opposition to analytical philosophy. So if you go to a department of philosophy in the UK, very often, although it's called philosophy, what they do is analytical philosophy. So what is analytical philosophy? Well, again, there is a kind of family resemblance there. So the idea that, you choose, I think you choose more the tools of logical thinking, making arguments in a clear way. That doesn't mean that continental philosophers cannot make an argument. They can. But for example, names like Wittgenstein, Bertrand Russell, John Austin, John Searle, Karl Popper, and analytical philosophy has been very good at generating subfields. So that's where philosophy of language, philosophy of the mind belong as well to this analytical. I think it's more like Anglophone, but not entirely. This analytical tradition of philosophy. And I think that actually, if we look at a kind of philosophy that's been closer to computer science, that's analytical philosophy. Yeah, that's where, sometimes normative ethics, when we look at the ethics of AI, the theory of language might have come from. So it's probably closer to computer science, so it's better known by computer scientists than continental philosophy, I think.
Yeah, I think that makes sense, especially because, we were discussing that with William too. I don't think there's much work connecting philosophy and computer science, unfortunately. And I don't think computer scientists, I don't think we know much about philosophy. But if someone has read something in philosophy, especially nowadays, they will probably have read something like philosophy of mind, right?
Yeah.
Or philosophy of language.
Yeah. That it's a useful tool. It's easier to kind of instrumentalize it in a way to, that's not in the derogatory sense. It can be more useful to computing than, continental philosophy. But for example, now that there are studies of the ethics of AI, responsible AI, and similar, it's becoming important to reflect on the social and political aspects of AI. So maybe continental philosophy might have something to say, or cultural and media studies might have something to say in that regard.
Yep, I think it makes sense. Okay, so I guess we can go to the book now. And I would like to start with maybe asking you, okay, what is the overarching theme, the goal of this book? So why did you write it? What was the main thing that you wanted to accomplish or to convey?
Oh, right. So I was trying to, I was interested in studying software because one is my background. So I'm a background, as a background, I'm a classicist. So I had a background in studying ancient texts and ancient languages, really. Then I was a software engineer. So I was also interested in computers. So I took a 1-year master in the basics of computer science in Italy, so to speak. And I learned enough to then become a software engineer, and then you learn the rest while you work. Clearly, I don't have the same background of a computer scientist, but I've done pretty much my 10 years of work in different software companies, software houses, and mainly telecommunications. So I've written my fair share of software. And then at some point I started thinking...
Sorry, can I a small interruption here? Can I tell the audience, you were writing low-level C code, and you said you were working on telecommunications. So Federica, what was that generation?
Yeah, that was the second generation of mobile telephony. It was the early 90s, the first half of the 90s, and that was in Italy, Milan, and I was in a research and development lab in a company, and we developed G2, which was the second generation of mobile telephony, but the first generation of mobile telephony to be entirely digital. And what I did was work on one of the layers of the protocols that keep the network or going. So yes, we did pretty low level programming, which I found extremely fascinating. C language and also some kinds of proprietary assembler on proprietary hardware. We even read some hexadecimal code to decipher the messages that we sent each other, because like a telephone exchange was obviously a kind of a big building full of computers that exchanged signals and handled calls. So yeah, it was quite fun, yes. And what I had noticed, given that I had a background mostly in literature, as fun as it might sound, is that programmers actually wrote a lot of code, and that was how I learned to program. Yeah, I knew the logical foundations, I knew how to do a flowchart, but reading this Bible, this massive standard specifications that came from CCTT, ETSI, the standardizing body of digital mobile telephony, interpreting them carefully and then translating them into some kind of code, and also working on inheritance software that I had to maintain or update, was pretty much the same as what I did as a philologist. So looking at texts really carefully, maybe in ancient Greek, and trying to understand them. So I was very, very interested in this idea. And at some point, I just decided, you know what, I'd like to write a book on this. And I was convinced that I didn't have enough conceptual and methodological background to do that. And that was probably true. So I decided to stop working in software and go and do a PhD in a place that allowed me to do so. And I found that place at Goldsmiths College in London. That's the part that is interesting. So this book was my attempt, one, at telling this story, and two, at make a meaningful intervention in cultural media studies, because it was quite early, but there were already people trying to explain to other media and cultural studies people what digitality was, what digital technologies were. And of course, they all realized that they were based on software. So describing what software was and explaining what software was the new big thing at the time. That's why the book is titled Software Theory, by the way, because the main object is software. The objective of the book is to say something of software that is obviously not technical, that is more understandable to cultural and media studies scholars. I didn't want to do what was happening at the time. So most of the studies that were emerging at the time, and believe me, those are great scholars, and I'm indebted to their work, scholars like Catherine Hayes, Alexander Galloway, Matt Fuller, Lev Manovich, Wendy Chung. They were people from either literature or media studies that were trying to explain to humanists, to people without a technical background, what software was and why it did what it did, and what it did to us and what we could do with it, and why digital media was so different from, analog mass media. And it was quite obvious to just make the technical quite, understandable. Go to the technical to explain the social. So this is how a protocol works. This is how software works. And I thought I was the first one to have come up with a very cool idea that software was a form of writing. But then, I found out that some other people were coming up with the same idea, which of course meant, that probably it was a good idea. If other people, were coming up with that idea, more established than me. But at the same time, I wanted to position myself in that emerging field, which has now emerged, which, was has different names. It's a part of digital media studies, but it has also found a proper name as software studies. Software studies is a part of media studies in a way. It asks of software questions that are typical of the humanities, such as How does it influence society? How is it shaped by society? Who has power? How does it shift power? And questions like that.
Mm.
And I wanted to found my own position in that debate. And my own position was this one in the book, to try and put media studies and digital media studies in conversation with continental philosophy.
I see.
That's how the book was born.
Yeah, okay. That's interesting. Here, if we take a step back about the objective, does it have like a central thesis that it tries to convince the readers of? For example, I think we should think of software as writing. Or is the goal something that doesn't have a main argument, but it's more about bringing two fields, let's say, like maybe software and media studies together? I don't want to call it like a comparative study, but it's more about bringing things, conceptual approaches together.
It does both. It certainly is an attempt to set up a dialogue between software and continental philosophy and also cultural studies, the kind of philosophy that can be done in cultural studies. So it opens up perspectives, but obviously there is a choice of authors because I'm not looking at the whole of continental philosophy. And so if there is one central thesis to this book, it's probably that this dialogue is really important and that we should look into software more from it as a form of writing, because that's important, because it repositions software in ways that are more complex. So deconstruction is the main conceptual tool I use, which didn't have a very good press at the time, but it had become acceptable again to speak about deconstruction in media and cultural studies at universities at the time. I try to show how software is always an unstable concept and how, even programmers, software engineers, computer scientists have been aware of that in a certain way. Maybe not fully aware of that, but they've been working with this kind of intrinsic instability of software all the time.
Right.
And this instability of software is kind of a driver to development of new technologies based on software, but it's also a risk.
That is definitely a theme of the book. The incalculable consequences of software, right?
Yeah, the unforeseeable consequences of software. I guess the book is not about calculability or computability of problems. It's about how technology always generates some unexpected consequences. And that's an interesting concept to look at. And it is more relevant. Sometimes it is more apparent in society. Think of now. Now it is quite a big thing with AI, with the recent development of AI. There is this massive debate about, are we close to developing a general purpose AI? Will AI overtake humanity? But that debate rests its face many times in many different fields in computer science, in my view. And that's why I look at the past and at some discipline like software engineering to explore how this fear of being overtaken by technology, while at the same this fascination with technology has always been there.
Yeah, I need to think more about that, what you just said.
We could talk about it.
That is true. I think I would like to go into some other questions that hopefully will shed more light into the book. And then we can hopefully come back to talking about the historical instances, let's call them, of fear of overtake by technology.
Sure.
Some terms that I think they appear in multiple places in the book, and I feel like they're probably not very known to people not familiar with the relevant literature. They were definitely not very familiar to me. And I think because they appear in many parts of the book, I feel like they will also help our discussion and also people who are trying to get into this book. So the first term I would ask you to explain is what does constitutive mean? So here I have some quotes, and at some point you say, I propose an understanding of software as constitutive of the very concept of the human. And then another part is iteration is a constitutive characteristic of software, just as fallibility and the capacity for generating unforeseen consequences. So what does it mean that A, something, that X is constitutive of Y?
Yeah, so I mean, I was not the one person to propose that technology is constitutive of the human. Of course, it was, for example, Bernard Stiegler and other philosophers. But constitutive is intended not just in the sense of forming a part of something, but also in the sense of having the power to give existence to something. Okay, so when I say technology is constitutive of the human, I'm saying that technology is part of the human, which is already quite a statement, but also the concept of the human, but also that technology enables the human to exist.
I see. Is it...
In this sense...
Oh, sorry, go ahead.
No,
I just want to ask, like, does it make sense to think of it as a necessary condition? Perhaps not sufficient. Like, for example, you can understand what, and that's more like what Stigler would say, that you can understand what a human is without understanding technology, or maybe a human as we know it, as we know them, cannot exist without technology. So in that sense, it's a necessary condition. I mean, a human has other aspects, but a necessary aspect is technology.
I think that's what Stigler is saying in Technics and Time, which is one of the texts I read closely in this book.
Sorry, just a small intervention here. I want to quickly mention, I have Technics and Time #1 here. It's in Greek, and I want to say that if there's anybody who's Greek, I definitely recommend this translation. And I'm just going to go ahead and say here, like publicly, this, in my opinion, is a better translation than the English translation. It's a really incredible translation by, this is other scholar, Rosalie Sinopoulou. So I definitely recommend that. Yeah, sorry, go ahead.
No, brilliant. Good to know. Well, yes, and Technics and Time starts from Greek philosophy. So the opposition between episteme and techne and all that.
Which you also mention in the book.
Yeah, I do. The important bit is that for Stigler, technology is very much a part, techniques actually is very much part of what constitutes the human. And this is the foundation of what he calls the tradition of originary technicity, which is a particular group of philosophers that think about the human and technology in a certain way as constitutive of the human. I don't know if you want to go into this level of detail.
We will go into that. I think I would like to discuss some terms before that, but I think we can go into that after that. Because I am pretty sure, I think the terms are important because I think they will resurface into pretty much every follow-up discussion we will have, I think. Yeah.
Yeah.
So we could summarize constitutive as meaning like some kind of necessary condition that is required for a certain concept or even a more physical entity to exist. Is that, would you say?
Yeah, for the human to exist, yes.
I mean, in general, of what constitutive. Like when we say A is constitutive of B, that means that A is a necessary concept for B to exist. Would you say it's okay?
Yeah, I would say that. I mean, I don't know if you're thinking also about Kant's understanding of constitutive.
No, that's interesting. What do you know?
So, but if I'm not wrong, in Kant, constitutive indicates principles that determine or constitute the nature of thing in a foundational way, almost like essential. And it's supposed to regulative principles, which do not define the nature of things, but remember that most philosophers apparently bring with them an insufficient understanding of Kant. This is so I'm not even a philosopher, right? Or not formally educated in philosophy. So take this with a grain of salt.
Okay. Yeah, sure. Okay, cool. The other term I think perhaps that we should discuss and that you've already mentioned is deconstruction or deconstructive. And I have a quote here where you say, I believe this is in the introduction. Although in this book, theory functions as a synonym for a deconstructive tradition of thought that draws mainly but not exclusively on Jacques Derrida's work, it also indicates a broader engagement with continental philosophy on the question of technology. So, what is that deconstructive tradition?
Well, the way I use deconstructive in that book is as a method for looking at software and other cultural constructs. Also, Jacques Derrida would probably think that I shouldn't say this. He would take issue with this because he states very clearly, quite often in his work, that deconstruction is not a method, that there is no recipe for deconstruction, that it needs to be performed in specific instances to see what it becomes. So I read Derrida at length before I wrote this book, particularly the Grammatology, which is a massive book. And also I had this fantastic mentor, Joanna Zielinska, who was very much using deconstruction, and Gary Hall as well, who, both cited in the book at some point, that gave me this perspective of using Derrida to look at software as a form of writing. So what is deconstruction? Well, the idea is to refer to, I think it's the letter to a Japanese friend, it's one of the short texts of Derrida, where he says that deconstruction is a way to look for a point of opacity in a conceptual system. So if you think of software as a conceptual system, or if you think of a discipline as a conceptual system, a conceptual framework, or if you think of anything as, a system, well, that discipline, for example, or that theory will always have a point of opacity, a point that needs to remain unthought, that's what he says, that is unthinkable within that conceptual system. So I know it's a bit convoluted to think, but for example, what Derrida does is he deconstructs the structural anthropology of Lévi-Strauss, right? This French anthropologist.
Okay.
And he works with binary structures. One of the favorite hobbies of deconstruction is to work with binary structures and then show that they are untenable. At some point, they become untenable. That's what he does. So Lévi-Strauss works on using this binary of nature culture, and it works. It's a beautiful theory, structuralist anthropology. But Derrida shows at some point that there is one point of opacity in that kind of anthropology, and it is the taboo incest.
Taboo incest?
Sorry, the incest taboo.
The incest taboo.
So the incest taboo. So incest as a taboo. And if it's neither in the category of nature nor in the category of culture, but it fits both at the same time. So why? Because it's universal, according to Lévi-Strauss. So if it's universal, then it must be nature. But it is not natural. It is in the sense that it's regulated by norms, social norms. That's not like, I couldn't, in principle, engage in that kind of sexual practice. It's just that it's forbidden. It's taboo. So it's undecidable if the taboo, the incest taboo is culture or nature. And that's the point of opacity.
Oh, I see. Okay. So just to be clear here, what you're saying is we're trying to describe what is part of nature, right? Or maybe, no, that's probably not what you said. Maybe we're trying to figure out whether incest, the incest taboo, is something that comes from nature or culture, right? Is that what you... Okay. And then we say, well, it exists everywhere in nature. So it's, or you say universal in nature, so we could say it's part of nature. But then obviously we think of it as a cultural thing. Like we culturally think that you should not do that. So you're saying that now it's really unclear where it belongs. But then, so it's a point of opacity. Well, what is a point of opacity of? Like, is it a point of opacity of nature or culture or both?
It's a point of opacity of structural anthropology.
Oh, I see. Which tries to explain some things based on culture and some things based on nature.
Yeah, and it tries to explain anthropology and human culture using binaries, especially the binary nature culture. So, what is cultural? Well, let's say technology is cultural, and then painting is cultural, and then, social rules and social norms are cultural. How about, this particular taboo? And generally culture is specific to certain peoples. It's not universal. So the incest taboo is both universal, which is the way in which Levi-Strauss, so this structuralist anthropologist, defines nature, but it is also regulated by norms, which is how you define culture. So it's a concept that doesn't fit or fits in both categories. It's difficult to place.
So would you say then, and I'm jumping ahead here, it's just what came to mind. I'm trying to bring, obviously I'm a programmer, so I'm trying to bring that to software to connect with the book. Would you say that then a similar idea is with iteration in software? In that it's some kind of point of opacity where it's sort of like, okay, so it's necessary, like you can't quite have software without iteration on multiple levels, like programs need iteration to do useful work. And then programmers need to do iteration to iterate on software to create it and perfect it, whatever. But then iteration also is something that creates most problems. It creates uncertainty. It's something that people don't necessarily understand. Like, would you say that, would you say that this is kind of accurate? That this is a point of, there's something there when it comes to software, when it comes to iteration, there are some opaque aspects of iteration.
Yes.
Or it in a way it convolutes our understanding of software.
Well, yes, a point of opacity is where you find a concept that is really necessary for software to exist, for example, but at the same time, it needs to be sort of pushed out of the software engineering in that case.
I see.
Because it's uncomfortable.
Yeah, so that's iteration, and that's part of the unforeseen consequences. I think that one of your themes in the book is that part of the reason that software has managed all this success, let's say, is the unforeseen consequences. But then you go in length into at least 2 chapters, probably 3. Anyway, at least chapter 3 and 4, trying to describe how a lot of the history in software engineering is trying to manage and calculate, or however we want to call it, contain this unforeseen consequences. So would you say that this is another point of opacity there, and this is the deconstructive approach to understanding software?
Perfect. That's exactly it. So yes, so software engineering, I chose that because it starts from looking at software as a form of writing, but actually what really does for deconstruction is that it tries to manage the development of software, time, and lots of what constitutes the unexpected of software. And it needs that to exist as a discipline, but at the same time, it can't. And so because it can't, it has to sort of, it's that tension between, the unforeseeable, the unforeseen, and the need for the unforeseen, but also the fear of the unforeseen and the attempt to control the unforeseen. And I think that's a dynamic of, developing technology in general, probably.
Yeah, it's very interesting, something I guess to think, particularly I guess for people who may be doing programming languages, who may be watching that. While I was reading these parts, I was thinking of something called WebAssembly. So that's something that was created, I don't know if you've heard of it, but it's something that was created originally in the paper. It was supposed to be a new standard language. It was supposed to be the standard language of the web, right? Like, okay, all browsers would be able to execute that. And then WebAssembly became big in the world of virtualization, which is a whole other thing, but basically, let's just say when you're trying to execute software in contained environments, like you have a single server and you have many virtual machines or many what people call containers. So they found that WebAssembly was pretty useful there because WebAssembly was created to be executed in the browser, it was supposed to be sandbox like contained. And they found that it was very useful for this other purpose. And people well, as far as I can tell, when people created, because remember, now that's not web, right? The containers virtualization. And it was very interesting because I was thinking that as far as I can tell, the designers of WebAssembly had never even thought of that. Not only were they, did they not make it their goal to support such cases, they were probably not even thinking in that direction at all. And the reason I mentioned that, and the reason I think is interesting, is because a lot of the book talks about unforeseen consequences that are negative in some sense. But this is, well, I may be wrong about that, but clearly this is like a positive consequence.
Absolutely, absolutely, absolutely. Yes, there are two kinds of unforeseen consequences here. One is the unforeseen uses of the technology, for example, which is this, or the fact that in the cathedral and the
Right.
bazaar, the argument is made that Linus Torvald was aiming at getting Linux working, and that model then became open source. And open source is considered a way to democratize access to software. But his intent was not to do that. It was just to get a working piece of
Yeah.
software, a working operating system. Yeah, or when I was a telecommunication software engineer, the idea that, texts, short messages, were considered a very unpromising technology because we thought, well, why would people, text each other when they can ring each other up? Yeah.
That's so interesting, That
Yeah.
is, yeah. I think you had mentioned somewhere else this before, some other interview, and when I heard it, I was like, "Oh my God, that's so profound!" Like, imagine being in that era, but like, I can't see why texting would be interesting. And then people just, I mean, now texting is everywhere, and to me, it's
Yes.
funny because I grew up in the generation that had texting everywhere. And we're ringing things
Yeah.
and videos, and generally this like more, I don't know how to call them, like more personal, maybe interactions were not a thing. When TikTok came up and this kind of culture, I was like, why would you want to use TikTok? Like, people would see you, that would be weird, right? It felt more natural, at least for me, and I think people around me, to use text. But then here we are, right? And like, TikTok is the new standard model
Yeah.
of communicating.
Yeah. And now that technology is evolving so fast, it becomes even more, more evident in a way. So I love discussing this with, again, my students, because it's really kind of, it's generational. That makes me feel very old, but it's funny. It's funny, and I also, don't get me wrong, I also text now rather than ringing people up, because it feels intrusive. So I generally ask them, maybe people who are in their 20s, early 20s, or 18, 19, do you ring someone up or do you text? And you can see the shifts sometimes in generations, so they used to text a lot and now they're going in the other direction. So anyway, so this is one of the surprises of technology. The other one, so this sort of technology is full of, wrong predictions, and misguided expectations. The other one is the unforeseen, that has to do with the agency of software. So clearly, when software does something, regardless of the uses of software. So, for example, when I compile and run a program, it might do something unexpected, something I don't expect. And again, that could be a malfunction, or it could be, an innovation. It could be something I'd not thought about, but actually is quite useful. That's where technology enters the picture in terms of technology as its own agency.
Yeah, that's a very long discussion, because I'm thinking here agency is a pretty heavy word.
Yes, okay.
Because in the sense that maybe it may be inaccurate, but when I'm thinking of agency, I think of consciousness. Although I think I get what you're saying. Like, clearly a compiler is not conscious, but it has some agency in the sense, okay, I give it a program and it can do stuff with it, and it may do something that I did not expect.
Yeah, that's what that means.
Pretty interesting also, I think, here is pointing back to the discussion with William. And I suggest that people watch that part to get the full context.
Years ago, early 1982 maybe, I was playing with the ELIZA program, a chat program that allegedly simulated a psychotherapist who used what's called Rogerian psychotherapy. In Rogerian psychotherapy, you don't tell the patient, the client, anything. You let them talk, and you might ask a few questions, or you might repeat what they would say. Joseph Weizenbaum, who was a computer scientist at MIT, wrote a program which he called ELIZA that simulated a Rogerian psychotherapist. You would type in, "My mother hates me," and it would type back, "Why do you think your mother hates you?" In other words, it was just echoing back. It wasn't really any kind of psychological advice or anything. People would get completely impressed by this and think that it was really psychoanalyzing.
And he was saying the story of how he was using Eliza at some point, and he was pretending to be, if I remember correctly, a character in Shakespeare.
So I was playing with Eliza once, and I typed in lines from Shakespeare's play Hamlet. And then I made believe I was Hamlet just to keep the conversation going. And at one point, the Eliza program asked me if something I had just typed was related to something I had typed at the very beginning of the interaction. And I had never thought that those things were related. I thought, wow, that was really interesting. Now, it wasn't comparing anything interesting. It was just saying, oh, here's something, I'll just put these two things together. But it put them together in a way that I had not put them together, and that made me think about the significance of it.
Okay.
I didn't realize it was significant, didn't even know what significance is.
But William's point here is Eliza was completely dumb in some sense. Like, there was nothing smart about Eliza. Eliza did not understand what was important or whatever. The compiler is also dumb in some sense, but when you combine the agency of the compiler and the unexpected with our consciousness and intelligence, it's sort of like you're fueling or you're creating this supercharged unforeseen consequence.
Yeah. The meaning we give to the word agency is probably more restrictive or broader instead. So it doesn't necessarily assume consciousness. So, for example, Bruno Latour's theory of actor network theory is a way to understand technosocial systems, right? So you can say that there are human actors, there are technical actors, and they don't necessarily have to have consciousness. But they all do something, and it's all interactions. So I interact with my phone, and that's a technical actor in that sense, or actant. You express that point really clearly. So we, in a way, from this perspective, we don't have to wait for, an AI that is really clever and conscious to have unexpected consequences. We see unexpected consequences all the time.
Right. But then when that is combined with our consciousness and intelligence, you can get really magnificent and unforeseen consequences.
Yeah, absolutely. Yes. But when is it not combined? In a way, we always exist in relation to our technologies, and our technologies exist in relation to us. So I would stretch that argument even further, but yeah, I know, I can see what you mean. Yeah. And also with Eliza, it's kind of a projection because, chatbots, even more evolved chatbots, sometimes you think, oh, what a nice chatbot, but it's your projection, of course.
Oh, yeah. Yeah. That's also an interesting thought. Yeah. So what you're saying,
Well, I tend to be kind to Gemini when I ask it for something, just because, please, can you rewrite this for the umpteenth time, but in less words, and it's just the way it kind of seems, right to treat it as opposed to,
Yeah, I think it makes sense. It's interesting here that you're saying that the intelligence of a system is at least partly in our perception. It's very hard to talk about like objective intelligence, at least partly because of the meaning we assign to whatever the chatbot is saying. And similarly, our behavior towards that system, so what you're saying, okay, me being kind, is at least partly, or in this case, probably completely because of our perception. Like there's nothing in the system that requires us to be kind or that will... There's nothing perhaps even instrumental. Like it's not like if I say please, it will give me better answers. So it's completely because of how we perceive it. For all we know up to now, the system doesn't feel. There's no point in saying please, but our perception of our interaction with the system somehow, I don't want to say enforces, but encourages us to be kind.
Yeah. I mean, it maybe if there is something in the system, it's just its potential to generate lots of useful answers for brainstorming, let's say.
Yeah, right. Okay, so I think this discussion was led by Deconstruction. I think we can also discuss the term technics, how you mean it in the book. Of course, I had to read a lot of Stigler. And it's very interesting that Stigler just starts page 1, assuming you know a bunch of stuff, including what technics means. So yeah, maybe you can give us like a short description of how you understand techniques, because from my reading, it's not exactly technology.
No, no. Technics is, well, it comes from Stigler, and I think that Stigler takes it from Heidegger. But if you look for a general definition of that, I would say technics is broader than technology. So technics is it's like an horizon where technology can exist. So technics is the possibility of developing technologies, the capacity, the potential of humanity to produce technological artifacts, while technology is more like a specific technology that happens to be that you can study. True that sometimes in the book I use the terms interchangeably, but only when there's no risk of misunderstanding. Generally, it is that way. So for Heidegger, we existed, we were in the world to interact with our environments, with certain things. Yes, this famous sentence that the essence of techniques is nothing technical. And then what he means is that it is sort of, part of our way to exist in the world. So yeah, techniques is the possibility to create technologies. Make sense?
I think it does. I think it does. I think my question here is, I thought that techniques is broader in the sense that it involves the potential, let's say, for skilled behavior. And the reason that this is broader is because, in that sense, logos, the skilled behavior of speaking, of communicating, would be part of techniques, because it's the result of very skilled behavior. And I thought that Stigler would think that logos is part of techniques. Then is, I think he talks about that in the introduction, that, logos is what is instrumentalized by, and Socrates talks about that too. But anyway, that logos is this thing that is instrumentalized by, say, for example, people who practice rhetoric. That they did it to convince, not to find truth. But in that sense, you can think of it as a tool. So the result of skilled behavior, it would be similar to a tool like a hammer, except that logos is not something. I mean, a hammer would be something that we would call technology, but logos is not something that we would call technology. So yeah, so maybe you can clarify that a little bit, because you're entrenched, so to speak, in this field. Maybe you can give us an idea of like what people think of generally techniques. Like would they call logos and things like that techniques, or would they usually think of just what we conventionally call technology?
Well, I think first of all, I think Stigler doesn't want to use the term logos, because logos is very essential, compromised with a metaphysical view of philosophy, and is trying to do something slightly different. So logos says, it's not about language only, but as you said, it's about
reasoning and
truth.
Yeah,
and finding the truth. So in that sense, it's part of what you are talking about, is part of that opposition between techne and episteme. And I think that for Stigler is central. It's central for me too. I mean, the sophists are part of that opposition. So the idea that goes back to ancient Greece and to Athens in the 5th century. So the idea that sophists were rhetoricians, and so they were not interested in finding the truth. They were just interested in teaching people how to win an argument, and to do that with rhetorical terms. Or, even worse, they were happy with instrumentalizing the truth to, political power, which is quite common in politicians anyway. So that's when technology and episteme, technology and knowledge, so techne and episteme, so technology and knowledge, or technology and philosophy, became opposed. And as we know from deconstruction, when there is a binary, there is very often a term that is valued and a term that is undervalued. So in that sense, episteme, knowledge, philosophy, is what, is concerned with the truth, with finding the truth. It's a noble enterprise. While techne is seen simply the using of instruments. Techno is simply something that exists to be used by others, and it has no interest in finding the truth. So this opposition was a political act that happened in Athens, and then devalued technical knowledge for centuries. For centuries. That's why technology for Stigler is a problem for philosophers in the sense that, especially continental philosophy, but in general, philosophy is not prepared to think of techniques as something essential because it's not concerned with the truth. Technique is just instrumental. It's a tool. And his theory is exactly the opposite, that technique is essential to the human, that it's not a tool. It's intrinsic to the human.
Yep.
Yeah.
I think that clarified it. Okay. The other term maybe we can discuss, and I don't know if you like it. I think I like it. I think these terms, they kind of lead us to many different discussions that are related to the book. I mean, I'm happy to go into the content. Feel free to, I see in some podcasts they have this ring where you click if you want to go to the next topic or something. That could be useful. But feel free if you want to go to more specific parts of the book. Happy to do that. But I also think that discussing the terms leads to tangents that are interesting.
Yeah, absolutely.
Okay. So the other thing I would like to discuss is historical specificity.
Yeah.
And that, I'm afraid I just did not really understand.
Okay. Well, I come from, this was still done in the context of media and cultural studies. So at the end of the day, I was talking to people who studied technologies and media technologies in a social and cultural context, and of course in an historical context as well.
Mm-hmm.
So yes, I'm talking about philosophy, but ultimately, when we analyze a technology, we need to look at the context for that technology. So at the historical specificity of that technology. Yeah. So if we are looking at software engineering in the 60s, well, it's not the same as looking at generative AI today. That's the historical specificity of technology.
Oh.
It's as simple as that.
But then, based on your description, isn't every technology historically specific? Like every technology appears at some point in history.
Yeah, yes, that's right. Maybe if I can add something, is the idea that sometimes instead of historical specificity, I talk about singularity, and that's a term that comes from Gary Hall, and then another important Hall, Stuart Hall, and another kind of foundational figure of cultural studies. So the idea that, again, there is an historical singularity or historical specificity to certain technologies or certain, moments in history or certain cultural moments. And I think it's important. I'm stressing it because I think it's very important now that we have this new, developments in AI, to look at AI in terms of why we have a certain AI at this particular moment in history. So Stuart Hall was he didn't study technology, but he studied a lot of other things. And he brings in at some point the term conjuncture, as in this conjuncture, meaning this particular moment in history where society is in a certain state of crisis that is both an opportunity and a crisis. My idea is that we have a certain kind of AI, maybe because we are at a certain conjuncture. And we could go, in different ways, which are going to influence the technology we have in the future. So it's kind of a big moment, sort of. And I think singularity is not the singularity that people talk about when they talk about the moment when AI takes over.
Yeah.
It's just the historical specificity of a technology. So I think it would be interesting to have a conjunctural analysis of AI, but this is for future studies. It's just my interest.
I see.
Looking at that. Yeah.
Okay. So I think, so just to be done with terms, I think one final term we'd like to discuss is temporality, and then maybe we can go to more specific parts of the book. But yeah, could you tell us a little bit what the term temporality is?
Yeah, temporality is basically the state of existing within time or of experiencing time, of having some relationship with time. To look at it as a broad concept.
Mhm.
Technologies carry the trace of past events. Stigler gives a very simple example. So the idea of the cutting stone, the idea of a prehistoric artifact. So if I'm
Yeah.
a prehistoric woman and I have this brilliant idea, or I make this accidental discovery that, a flint or stone, a sharp flint or stone can be used to cut. And then, of course, I use it, and maybe I'm able to make another one. But then when I die, my knowledge dies with me. But if the flint or stone is left there, then it carries with it the memory of the act of cutting. So that's the way Stigler thinks that technology shapes our sense of time and history.
So can we say that a technology, say, changes our sense of temporality? And does that mean that it makes our experience time differently?
Yes, yes, because it gives us, for example, a sense of history, a sense of our past, and a sense of the possibility of sharing unlived experiences we haven't lived, and
Yeah.
maybe others have lived. Also, yeah, if you want to go into the specifics, of course, think of the time of cinema, for example, the temporality of cinema. I don't know how many people still go to the cinema, but when you are in a cinema watching a movie, and you have to follow the time of that movie, as opposed to multitasking on your computer or doing other things.
Yeah,
So yeah, it does change your experience of time, and cinema is a technology, of course.
that makes sense. So I think what you just said about the experience of time is a very nice opportunity to go to something that I would like to discuss. It's about our experience with past technologies and also how technology evolves over time. So this is from a talk by Jonathan Blow. It has this dramatic title, Preventing the Collapse of Civilization,
Yes.
which I find very interesting. I think it's an interesting talk. This talk has a bunch of theses of the first half or so. And one of them is that technology naturally degrades over time. Obviously, you can define whatever naturally means. Because, that's a little bit unclear. What does it mean to leave technology on its own? Because that's, I think, what he means. And he also, he played a video of Elon Musk saying the same thing. I can't tell. If you ask me what exactly does it mean to leave technology on its own, I'm not sure what that means, right? So maybe if you think it's important to give some kind of definition there to answer that, feel free to do so. But they say, okay, technology degrades over time, and what is now related to what we just said about temporality and how we experience the past is that to support this thesis, Blow gives a bunch of examples of technologies that have been lost.
Yeah.
My favorite example by far is this example with, it's a cup. If I remember correctly, it's called the Lycurgus cup. And it's this cup that is, let's say you're looking at the cup. If the light is coming from the back, it has, I believe, this greenish kind of, it's an earthly color. Okay, it's a little dark kind of greenish thing. But then if the light is comes through the cup, like let's say you're looking at the cup and the light is behind you and is hitting you through the cup, then it has this light kind of pinkish, it illuminates almost. So that's very cool. Obviously, it was created, I believe they have dated the cup somewhere around 100 AD, right? So many years ago. And Blow says, I haven't verified that, but I think it's probably correct, that people were trying to figure out how they did that for so long. And they finally figured it out in the 1995, like pretty recently, right? It's insane. And they said that the way they could reproduce it is by some kind of nanomaterial, basically, that is so small that you can't see it with a physical microscope. And you kind of, somehow you infuse this material and you get this effect. And now, basically what Blow says is, look, we've just lost how that cup was made. Probably that's not how they made it. So maybe you can comment on technology naturally degrading over time. And also maybe there's a second, when it comes to intergenerational transfer, what Stigler would call mnemotechnics, there's an aspect which is transferred automatically, let's call it, which is what this thing was used for. And that's even debatable. But okay, let's just say that usually you don't know of a hammer. If I give you a hammer, probably we're like, okay, what can I do? Oh, people were probably pounding stuff. But it's a totally different level of like how you make a hammer, how you make the cup. Do you think that's something, because I didn't read a lot of analysis on that aspect from Stigler, maybe I'm missing something. Do you think that there's a whole second level when it comes to intergenerational transfer of knowledge that has to do with the how?
Yeah. Well, this is a complex question.
Okay.
So, yeah, my first instinct in terms of the Lycurgus cup was exactly that, not focusing on the how, but on the fact that is deciphering the object anyway. So there must be some knowledge that is inscribed there or, easily readable there. So, okay, the way they made it, translucent or whatever, is lost forever. But what makes him say that it is a cup? Because, quite clearly it is a cup. So its use, as you said, for the hammer, its use is kind of almost obvious. So he has a point, and there is a point in saying that the memory of how things are made is more difficult to dig out, to preserve. So there is a point, there is something that we can preserve, that technology preserves. And that's what Stigler is saying. It preserves the memory of its use, maybe not the memory of its making, but the memory of its use. And some technologies, of course, are lost. Others can be misread, of course, because what if that cup is not a cup? Maybe it was meant for something else that is not immediately obvious to us. But also archaeologists are familiar with this problem, I think. So I never thought of it in particular terms because, archaeologists, what they do is excavate objects all the time and then interrogate these objects. And it's quite common, I guess, for people to discuss even the uses. So, you can find a mysterious object and, what is it? What was it used for? I think it's a clock. No, it can't be a clock. I think it's a calendar. And it's difficult to figure that out. So, but memory, I think that what Stigler is arguing, and I think I pretty much agree with that, is not that nothing ever gets lost.
Okay.
But that memory is a complex process. Okay, so we remember that it's a selective process of memorization. So of course we forget certain things and we memorize others. And in the same way, there will be lost technology, there will be lost languages, there will be, lost mnemotechnics. Think of the Rosetta Stone and how long it took to decipher, parts of ancient writings or dead languages that don't exist anymore. So there are variations in the way that the memory is transmitted and the memory of what is transmitted. And also, I think that the interesting blow is talking about the end of civilization. So for some reason, is giving technology the power to end civilization. So it's attributing an immense power to technology. Is implicitly recognizing the constitutive role of technology in civilization, culture, in society, and so on. So for him,
sorry, go ahead. It's just, go ahead.
No. So for him, degradation and loss is the norm, right? And he might have a point. He might have a point in the same way that, for economists, this view that crisis is the norm and actual moments of prosperity and growth are quite the exception. I think his thesis provides quite a nice counter argument to the hype that is surrounding technology when there is a hype about new technologies like AI, accelerationism and all these. So I don't know if it's so deterministic, if it naturally degrades, that technology naturally degrades. I wouldn't say so. The other, sorry, you wanted to say something?
It's just, I guess that makes sense. And I guess the other thing that I think is interesting in Blow's talk is, as you said, he talks about the end of the collapse of civilization. But interestingly, most people, when they talk about the collapse of civilization today, they talk about AI taking over or something.
Yeah.
But Blow makes a very different argument, and I think that's interesting. I don't know if that's what you, were hinting at, that we are very dependent on technology right now. and we're dependent on good software. And that is going away. And that's why the civilization will collapse. It's not because AI will take over.
Yeah, true. True. Yeah, so this is that we don't even expect technology to work anymore. So we are kind of losing that way of talking about technology that has to do with quality assurance, quality control. We are getting used to being less and less competent. Programmers are okay with using a lot of black box languages, high level languages. They have lost the capacity to program at low level
Yeah.
with low-level languages to be close to the machine, and that's a memory that if it's not transmitted, a skill that is, if it's not practiced, it will get lost. And then at some point, what happens? Nobody will be able to fix technology anymore, and if it breaks, then everything breaks. But I think partly that's true again in terms of how perhaps people don't expect perfect technology or technology that works all the time or that is really, really high quality anymore. It's possible. I mean, again, I can hear lots of people saying, using different kinds of generative artificial intelligence or different kinds of, I don't know, conferencing software, video call software, and saying, that software is crap. How about this other software? Oh, no, it's just like it's difficult to share materials. But so we have this kind of low expectations of technology.
I have a question on that, but feel free to finish.
No, you can ask.
So one thing I want to say is that it's interesting, first of all, how that the contrast with what William was saying in his papers, of how he tries to persuade people not to trust technology too much. That some people think that this neural network-backed chatbots are, they think that they're better than they actually are. So that I think is an interesting point of contrast. But the other thing I would like to ask you to comment on is this anymore part. So Blow says we don't expect software to work anymore. But there's this Garmisch report, I don't know if I'm pronouncing it correctly, that you mention a lot in the book. And it seems that people, so I have here page 75 of this guy's David and Fraser. So there's this, oh well, I really hope I will find it. So you say, this is what David and Fraser state, quote, particularly alarming is the seemingly unavoidable fallibility of large software, since a malfunction in an advanced hardware-software system can be a matter of life and death. And I went and looked at when the Garmisch report was published. I actually didn't know about this report. Pretty interesting. I got introduced to it through your book. And it was published in 1968.
Yep.
So it seems that people were making the statement of we don't expect software to work anymore, like back in 1968. So what do you think about that? I would like to ask you, because for many of us, like especially many people who have not done a historical study into past statements, many people who just hear what people say on Twitter, they may think that like even in 2010 software was absolutely amazing, and it's now that people think that nothing works.
Yeah, I mean that I guess that's what was trying to that I was trying to get to that point. So this is the recurring argument again, this kind of fear of failure, fear of technological failure, but also fear that quality is degrading for this and this reason. I remember in the 90s when I was still a programmer and I was in Milan and there was this kind of rumor that the new line of the underground in Milan would be entirely software piloted, driven by software, which
Yeah.
I don't know if it was or if that happened later, but certainly now it is a thing. And programmers joking that knowing how software is made, we would never use that line because it would crash at some point. So there is an acute awareness of, the fallibility of software. Now, I also think it depends on the field of technology. So I imagine that, leaving aside jokes on underground transports, when you have a real-time system, for example, or a system that operates in highly risky situations, well, I'm not sure we are so prone to, accepting lower expectations. You cannot really have a plane, where piloting is done or is aided by a software that has a lot of downtime. And again, I remember that the standards for telecommunication and telephone exchange had a downtime of, Blow talks about the 5 nines.
Yeah, yeah.
So yeah, it needs to be up 999.99% of the time. Yeah, the exchange had a downtime of maybe a few seconds in a zillion years, something, almost unrealistic. So it was not expected to have downtime, but of course it had downtime. So I guess, yeah, the Garmisch report is very much, yes, about that. But and there you can see that risks are magnified because it was done. That conference was conducted during the Cold War. So of course, the scenario was that it was that of a software that was used for, armament, ballistic missiles, or like kind of, very very real time technologies that had the potential to really really have catastrophic consequences. So there is this sense of the catastrophe, of the possibility that software not working, and also there were very large systems put together by many people. And I think I experienced that kind of a bit later, but I experienced that kind of project where there are hundreds of people producing thousands of lines of code, tens of thousands, and it's very easy to have something wrong or something that doesn't communicate well or assemble together well. So this sense of the potential of failure, I think, and that sense of, I mean, what is important in the Garmisch report is that people do not look back and think there was a time when software was done well and now we can't. That's the difference. So they are quite,
yeah. Because
they
also
are
it was in the very beginning, so to speak, of software, almost.
Yes. Yeah. So they don't have this part of looking back and thinking people used to be able to program and now they aren't anymore. They're actually at the point of saying we have these massive software systems and it's so easy for technology to go wrong. And if it goes wrong in these risky situations, what happens? And so they saw that the way to avoid failure was to make software production, software development more similar to engineering. That was the way to go, which was actually, basically applying project management principles if we really look into that. So this sense of failure, expectation, skills, losing certain skills is very, again, context related. So it depends on the kind of application. So I'm pretty sure that, real-time technologies in risky situations still have to be programmed at a quite low level, and there are certain standards to avoid downtime. In terms of the black box thing that Blow is talking about, when he says, yeah, programmers don't bother with, assembler or C language anymore. They're okay with Java or with very high level languages, or even, picking software from libraries, routine from the internet, you name it. The question I would ask is, well, is that the fault? Is that really the fault of programmers? Is it, the programmers' fault? Is it because of intellectual laziness? Or is it something else? Because we are using a lot of black box technologies this day. And it's not that the programmers make the technologies black box. Because if they are proprietary, they are black box.
That's not necessary though, right? Because I think what Blow is talking about is similar to, well, let's say that you're using an open source JavaScript library.
Okay.
So you can read it, but people just don't read that. I think mostly that's what he means. And then it's interesting, I think probably Blow, what he's talking about is what a lot of people talk about this famous or infamous software stack, where it's like, okay, you have this library that is executed on Python, and Python is executed on the Python interpreter, and the Python interpreter is based on C. And I think that what he's talking about is that a lot of people have, like, for example, absolutely no idea how Python is executed.
Right.
Now, that said, there's a lot to be said about hardware and opacity.
Yeah. Yes. Yes. Yes, definitely.
If you want, I can ask a related question to that.
You can try.
Okay. Yeah. No, I was just.
I don't know if I'm able to.
No. It's like, so because what I'm thinking of here is, I think part of the unforeseen consequences of software have to do with the fact that we don't know how hardware works.
Yeah.
Now, here, in my mind, there are two sides. One of them is that hardware actually gives us surprising guarantees, and a lot of the unforeseen consequences are things that we have introduced. And so that's something I think Blow also talks about, but for sure many of us talk about in many different contexts and compilers and whatever. That, for example, x86, the architecture from Intel, is surprisingly stable. If you have a binary that doesn't make any system calls to the operating system, right? Let's say it does computation. You can execute the same, assuming that you use instructions that are available through generations, but you can execute this thing in a CPU from today and a CPU from like 50 years ago or whatever, and it will do just exactly the same thing, right? So it's surprisingly stable. And not only that, but it's also that, like, if you take this, you take the same piece of code and you execute it on your Mac and my Linux and the other person's Windows, it will do exactly the same thing.
Right.
So it's interesting that a lot of the, I don't know if that's what you were talking about unforeseen consequences, but I think it is. A lot of like, oh, I created this program and now I'm running it on my PC and it does a specific thing and then I send it to you and you run it and it's like, either it doesn't even run because my thing was compiled for Windows, but you run Mac, let's say, or it runs and it just does something completely unexpected. And a lot of it is not because of the hardware. Like, the hardware is extremely reliable and also well defined. It's not just that it's like, it's going to do the same thing, but we don't know what. It's also, we know what it's going to do. But it's just a lot of things that we have piled on top, the software that we have created. So that's the one side, right, of unforeseen consequences, of basically us piling up stuff, whereas hardware is pretty good in terms of what it will do. The other side, though, what we don't know is the how. We don't know how the CPU does something. We know, for example, that, if I give this two operands to an addition instruction, as you know, it will give me this result, period. But how it will do that, I have absolutely no idea. And that's a big problem when it comes to unforeseen consequences, especially when you try to figure out, say, performance and energy efficiency. Like, okay, I can know what my assembly, what the result I'm going to get. But in terms of trying to predict how fast it's going to come out and how energy efficient it will be, I practically have no idea. And I was listening to a presentation by Sebastian Hack, and he was saying, and compilers will try to predict these things, but part of the reason we suck is because we have really shitty cost models of hardware. So
the thing is we have absolutely no proper models of the machines that we're compiling for. The abstractions that we use for the hardware are so super simplistic. It's really, really hard to have a precise understanding of the machine that you're compiling for. And it's, I guess, even harder to have algorithms that are able to read the machines that we are compiling for.
Anyway, I've been talking a lot, but maybe you can tell me, I'm interested in your opinion in these kinds of unforeseen consequences, that on the one aspect, we have a lot of certainty from the hardware, but we pile stuff on top that creates uncertainty and unforeseen bad consequences. On the other hand, a lot of it we can't solve because it's just opaque.
Yeah, that's absolutely true. And I think that that's exactly it. It's a problem of building layers up. It's a problem of perhaps, I don't know if it's silos of knowledge, but I remember when I was trying to write the last chapter of the book about compilers, and I might have said something really wrong from a technical point of view. I was trying to ask colleagues in computer science to review my technical interpretation of things.
I think it's solid. Yeah, for the most part, I think it's fine.
Thank you. That's fantastic. But, I was trying to basically say something different than what media studies people were saying about software, that it's a process of translation. So, you go from high level to low level code until it becomes the hardware. And then there was Friedrich Hitler, this famous philosopher of media, who said, well, then there is no software then. There is only just hardware. Then there are, high-level ways of manipulating the polarities on a disk or whatever he calls them. But, at the end, there is no software. That was the polemical title of his article. There is no software. And I was thinking, surely it's, I wanted to see how it happened. So what does it mean to say that, a compiler spits out something that then becomes the concrete operations of the machine? What does
Yeah.
it mean? And, that's why I talk about software in terms of transcription or transcription, to the point that even the configuration of hardware can be considered a transcription, some sort of the high-level programming. Now, that's, it's not the right term, probably. But what I noticed was that I was asking people who had been programmer, ex-colleagues, people who had, formal education in computer science, and there were always points where they stopped and they didn't know how it progressed.
Yeah.
What was the link between, okay, and then at some point, I guess, there is a circuit or something that does this, or there are logic ports, or so it was very difficult to understand. I don't know if it's silos knowledge or if it's something else, but that's one of the reasons of unexpected consequences. And even if software has become very portable, I guess, and very stable, there are also, contrary to what Blow seems to think, for example, there are very low-level languages that allows you to do a lot of damage because, imagine using a pointer. There was a time when, using a pointer in C was, of course you feel so cool because you think you can go exactly to that memory cell and move something there, but with C, using pointers. But, they are also extremely dangerous because they were not portable at the time. So you can have a pointer somewhere in the software that points to the wrong memory cell because something has changed in the hardware, and it creates a massive bug that is unfixable almost. So I think that is one of the problems. Yes, that sort of almost the opacity of hardware. Yes, it's the opacity of hardware. Yes.
So I want, if you want, to me it's very interesting if you want to discuss this, what you just said of software, like there's no software. Or it's just hardware. Is that something interesting to you? To me, it sounds a bit interesting.
I don't know, but if you want to try and try to talk about it.
It's okay. I was mostly thinking in terms of, let's think of a high-level language. And it's important because, well, pretty much all languages, but anyway, it's easier to think about high-level languages. They have abstract semantics, as it's called, and it sounds very fancy, but basically what this means is that they describe what should happen independent of how it happens. So a program basically that says like x is equal to 1 plus 2, the abstract semantics is that x should get the value of 3. But the thing is, then you have the implementation by the compiler. And this, when this program is executed, it may happen different in your machine than in my machine. So how is it that when I wrote the program, I wasn't programming a specific piece of hardware. I was writing an abstract program.
Yeah.
And I'm not talking like abstractly here. I'm talking very concretely. It's impossible because the program is executed differently on your machine and my machine. And it doesn't either make sense to think that I'm programming all machines at the same time because the program can be executed in the future in a machine that at the time of writing the program I didn't even know existed. So to me, it's a very foreign concept to say that everything's hardware.
Yeah. He wasn't a programmer.
So I have two last questions on the book. Yeah, I really want to know what you think about them. One is on page 90, you say something interesting.
Mm-hmm.
You say not only does one find out what the system does only by constructing it, the original ignorance of what the system does is constitutive of the system. So this, I think, is related to what we were talking about earlier, about the transfer of knowledge, the intergenerational transfer of knowledge. And what I mean is, the first question is, can you then truly understand something you have not built?
Mm.
And if the answer is no, then we don't have intergenerational transfer.
Mm. I understand the question. I think what I was trying to think there was not about generational transfer, but about the way you develop a software system. So because of these complex systems, the Garmisch people thought that the only way to make software less of a crafty thing and more of a streamlined, manageable, industrialized process was to write detailed specifications and then detailed architecture, detailed design, flowcharts, you name it, and then move on to the level of implementation. It was basically project management with the waterfall model, but they don't say this in so many words, but it is what it is. And so their problem was that you would have to have a problem out there in the world to which your software constitutes a solution, which is not necessarily true. But anyway, that's what they wanted to, that was the narrative they wanted to build. And then you would have to know the solution and to know it perfectly. And then you would have to write detailed specifications that told you exactly everything, the what of the system, everything that that software system would do. And then you would freeze the specifications and then move on to the architecture or the design or a more detailed level. And when that's completed, you would move on to the implementation. Okay, and possibly different people would do different parts of different stages, and these stages needed to be separated. That was the way they thought of it, because that made it linearized, tidy. It governed, it managed time very, very clearly. But the problem is that, as we know, that's not the way the software is developed or develops anyway. The way it develops is that you go back and forth between these stages to the point that you can say that actually, at some point, your specifications, there's not even, we don't even write specifications anymore, I don't think. That's not the way that software is developed anymore. There are more agile way of developing software. But even then, even when you wrote detailed specifications, what happened was that you moved on to the level of design and then the level of implementation. And then when you implemented something, that brought up some inconsistency in previous stages. So you had to go iterate back to the specifications and adjust the specifications, change them. So it could be just, a typo in your code that generated a mistake, or it could be that your code identified a mistake that went back to the level of the design or the specification.
Yeah.
Yeah. But so in a way...
So you do agree that you can separate these two?
You can't separate these two.
Yeah.
You can't. You can, and that's the point of opacity or the deconstructive reading of software engineering. So when I read it, I say, well, these stages, these ideal stages of knowing what you want to do and then knowing how you want to do it and then planning how to do it and then doing it, conceptually have a meaning. You in a way, it's okay that you have to maintain them in your mind to, give it some kind of order or give it a narrative. But in reality, they become undone, as Deconstruction says all the time. So these boundaries between stages are transgressed all the time because you go back and forth. You don't go just, in one direction and so on. So if you take this to the extreme, you realize that actually the way the software develops is by going wrong or by generating unforeseen consequences. So, as I said, sometimes it could be just a simple mistake in the way you've coded, but sometimes it could be that you find some inconsistency in the specifications. Even at international standards level, it can happen. So, very often when the implementation starts of something that is regulated at a very high level, at international standards level, the implementation can identify errors in the standards. So you have to write to the CCITT or the ETSI committee or something and tell them, I think there is an error in your flowchart. And they will actually correct the flowchart. So it's iterative. So what I wanted to say with this reasoning was that, we like to have this linear conception of time, and iteration is kind of seen as the exception when in fact it's the norm. And the result of that is that we never know perfectly what our technology, what we want our technology to do. We think we do. We think we know what it wants to do, what we want it to do. And then we start developing it because we have to start at some point, even if we haven't, if we are unaware of the parts that we don't know. These are unknown unknowns, sort of. Yeah. But then when we start making it, building it, there might be instances where we actually have to go back and think, no, actually, Why is it doing this? Do I want this or do I not want this as part of my technology? And so you write the specifications. So your ignorance of what actually you want to do in that system, your ignorance of what your technology is supposed to do, supposed to be, is constitutive of the very process of creating it. So you start without knowing exactly everything. And that's okay. And I think that became the foundation of agile programming later. That, iteration and change and the unexpected are actually the norm rather than something to be controlled.
Yeah, I think that makes sense. Yeah. It's nice that we discussed that because that was one of the things that stood out for me. Brooks talked about that. I mean, I think most programmers are familiar with Mythical Man Month, but the Garmisch report also talked about that, and I was not familiar with that. And it's something that is very against, I think, as you said, most people's experiences.
Yeah. Yeah, one of the comments I got very often when I was looking at this part of history was software is not written like that anymore. It's just, and I was thinking, yeah, no, I get it. Even though I'm not that old, I'm not that ancient, and I've still seen big systems programmed that way. But that's not the point. The point is that it's always a matter of trying to control technology and actually having to give up control for it to develop in a way that is creative and interesting.
Yeah.
Sorry, I might have interrupted you, but I was thinking of musicians and, my interaction with musicians at some point after publishing this book. So when I was on Resonance Radio in London, this person who was a musician put me in contact with another musician because he had read the book and he said, you need to talk to Mark Fell. And Mark Fell is an experimental composer who does a lot of electronic music, but also experimental music. And so we started talking and we've done an article together where we talk, we have a conversation really. And, he's saying exactly the same thing, musicians, composers, what do? They don't start with an idea of what, the music should be, and then they go out and they make it, they start playing with stuff, at least electronic musicians, they start playing with synthesizers and do something and see what comes out. And then, they produce stuff. And his interesting experience was that when he used to teach composition to students, he said that students have this kind of Platonic conception of creation, right? Yeah. So I start with an idea and then I go out and I realize it. My students who do, digital contents and other kind of software, web development, lots of other things. They think or a marketing campaign or something. They say, I will have an idea and then I will develop it. And it doesn't happen that way. They start playing with things and then they test it, they show it to the user. And then, that's kind of test-driven development. And then they come back and they do a bit more. So I guess the fact that we are trying to think of certain processes in a Platonic way, sort of like, the mind comes before the body, the idea comes before the realization, my brain comes before my hands. It's quite common, but it's not how it works, really.
Yeah, very interesting that you're mentioning that. First of all, the one thing is you reminded me, this thing was supposed to be in frame, but it never got into frame. The second thing is you reminded me of Stigler of when he referred to something, well, to Marx and Engels, of how they were saying that like the hand developed along with the tool. So it's not like, oh, I have this hand, let me develop the tool. It's like these things kind of co-developed.
Yeah, that's the sense of originary technicity that, the evolution of humanity is the freeing up, as Leroy-Gourhan said, is the freeing up of the hand from locomotion when Homo sapiens, stands. Yeah. But at the same time, the freeing up of the mouse from finding food and actually being able to talk. And so technology and humanity develop together, and the hands and the mind are not opposed. But Brooks, for example, the chapter on the Mythical Man Month, is an extreme of that kind of reasoning. I mean, that's a book that actually, I think, the issues of the Mythical Man Month can probably be resolved or is treated today in different terms by, I think it doesn't distinguish very well between work effort and real time estimates and how you schedule time and so on. But anyway, this is the problem with the Mythical Man months and with Brooks' theories, that he superimposes this kind of Platonic view. So, there is the few people who are the brain and have the idea and develop the abstract system, and then other people who are the hands actually, and they must make choices. They must implement the system, but the room for them to make choices needs to be really, really restricted, so they can cause the least possible unpredictable effects or changes, because they just have to execute what the mind has thought. So it's the pure genius who devises the system, and then there are all the people who execute, who implement it.
Yeah.
It's political. It's a political decision, isn't it? It's like the basis of industrialization at a certain point.
That's interesting. Can you expand on that?
So the Garmisch people were trying to industrialize software development. That's the term they used. They said engineers have industrialized most of what they do, but we haven't. And they meant we haven't streamlined it. We don't have a model for producing software. It's interesting because at that point, software is starting to be seen as a product, as a commodity, something that can be commercialized. And Wendy Chan has written something very interesting. Around the same year, this book came out about software becoming a commodity and therefore copyrightable, and therefore, source code becomes important because it is the thing that you can sell, sort of. So they wanted to streamline this process, and they want to make it so that this is the word they use, industrialize it. Brooke was kind of feeling a bit in despair. He was saying, well, we'll never get there, because no matter how much we try, we'll never get to that point. And so he was said, we need to be really strict. There needs to be someone with the idea, and then there needs to be the people who execute, the implements the idea. And I think that's again a political decision in terms of maybe not just industrialization, but I'm thinking now, for example, of the process of change that we're seeing in British universities. I hope I can say this in a podcast, but really, it's very known. This, when since the start of, so we had
the industrialization of education.
Yeah, but it's not just that. This is okay to discuss, in a way, but there are changes in the university system now. So in Britain, there was a time where lots of universities, new universities or modern universities developed, which are called post-92 universities. This is a properly UK term. So it was ex-polytechnics, so-called polytechnics, which were basically vocational schools where, you formed, teachers, nurses, different kind of professionals, and they became universities. So polytechnic is a different thing. So lots of polytechnics became universities. So they started offering a wide variety of disciplines, and including, the humanities, the arts, and so on. And now there is the opposite process going on. So a lot of modern universities, or even other universities, research universities, even elite universities, they are experiencing this process of disinvestment from the government, really. Oh. And there is a general...
That sounds like what's happening in the US now, but I didn't know that there's something like that happening in Britain.
Yeah, there is absolutely. Actually, that's happening on both sides of the pond. And the thing is that, it's the ideology behind that is that, people are not meant to actually go to the university. They're not meant to get degrees. Yes, there was a time of expansion when everyone wanted to get a degree. Yeah. Everyone wanted to get a degree, and that's okay because it was a time of economic growth. But now, really, we need to have fewer people going to university, and most people go looking at more vocational degrees. And so there is a chance that lots of universities will go back to being polytechnics, except that, instead of nurses and teachers, they will be training people in computing or business or, some vocational subjects. That's the name for this kind of degrees, vocational degrees. Yeah.
I see.
So more practically oriented. But that's a political decision, isn't it? It's like only a few people are meant to study Shakespeare. Who needs Shakespeare? You need to learn how to make things, and they forget that actually, maybe not Shakespeare, or not Shakespeare specifically, but lots of things actually require thinking. You cannot just be a vocational person. What does it even mean? And so it's a general view of knowledge as hierarchical, sort of, and reducing the access of people to ideation, to concepts, to.
This is such a long discussion and very interesting too. One thing I'm going to say is that here in a PhD in computer science, what you will hear often is, or not often, but I've heard it phrased, let's not talk about philosophy. And that happens when you try to talk about conceptual aspects or maybe ideological aspects of your research project. People are like, let's just focus on the work. And that's sometimes, sometimes I get it, because sometimes you can get into vague and unproductive and irrelevant arguments. Although to me, that's not what philosophy is about. I think people have, especially people in computer science, because usually we don't know much about philosophy. I think they've just labeled anything that is irrelevant, abstract argumentation as like, oh, that's philosophy. But it's very weird, especially if you think that this is supposed to be a degree, like, PhD, right? A doctorate in philosophy. So, and I know that's nowadays just a name, but I do think that it's supposed to be partly developing a way of thinking.
Yeah, absolutely.
So actually, I would like to ask you, if you don't mind, we can move away from the book into some general questions. Sure. One question I would like to ask you here is, it's a question that has been bothering me for a long time now. And it's a question that I asked to Sebastian Hack. He's a computer scientist and a compiler expert. But our discussion was very much, I like to think, philosophical in the good sense. So anyway, the question I asked there was, it's what I summarized as a PhD as a social training program.
Uh-huh.
And what I mean by that is, to me, a PhD should have been about partly studying philosophy and then developing, I don't know how you want to call it, philosophical, ideological, theoretical, I'm going to call it philosophical understanding, or a philosophical stance on how research should be done and what is good research. And that is not just about abstract things, it's about very practical things like, what is a good experiment? What is a good experiment? When have we evaluated a system correctly? In general, what is good evaluation? In some cases, it's a proof. In some other cases, it's an experimental evaluation. When is something novel? And that's a very big discussion.
Yes.
But that doesn't seem to be. In my experiences, that's not what a PhD is. And, not to put UC down, it's a great university, one of the top universities in the world. And as far as I know, though, the same thing happens in other universities, top universities. And here's what I mean by a social training program. I mean that you come to the university and you learn how to appease certain communities to get ahead. Let's say I'm a programming languages expert. And in programming languages, we have two star conferences, two major PLDI and POPL. And I think that a big part of the PhD experience is, how do you write a paper about PLDI? And what that means, just to be clear here, is how do you write a paper so that it gets accepted to PLDI?
Yeah.
And I think that is a big problem, because that's what I mean by a social training program. You're not thinking of like, what is good research? Okay, let's do that and then let's write a paper about it. I think a lot of it is, how do I appease certain communities? And a lot of it is similar of like, hey, how many papers do I need to have a good chance in the academic job market?
Yeah.
Instead of like, how can I be as a successful researcher, where successful means doing good research. And doing good research is different for different people, and I think that's fine, right? But I think part of the PhD should have been trying to find your personal trajectory, if you will. Like, what is important, what is good research for you? But I don't think that's what's happening in my experience. I'd like to hear your thoughts on that. Of course, I only have an experience from computer science. I guess it's similar to STEM, but I have no idea how it is in the humanities.
Yeah, I mean, I guess it also depends. I mean, in my experience, it might depend on your supervisor. It might depend on, in my experience I have in the UK. But
I agree, and that's definitely, sorry to interrupt you, but I do think that's important. I do think it depends on your supervisor, and I do think that a really practical way of going about research is something like, look, let's define separately how research, what good research is. But then reality is we need money and whatever. We need to write grants. We need to get papers accepted. Okay, whatever. Let's do the good research. And then let's also try to do this kind of thing just to get it going. Yeah. So I agree. And to me, that's a different version of the social training program. That's you need to think what good research is for yourself. That's different from saying, don't think what good research is, just learn what PLDI likes. So I just want to say, and that I think depends a lot on your advisor. And I personally, I'm glad to have had good experiences on that. But sorry to interrupt you. Please go ahead.
No. Yes, we agree on that. But the institution probably feeds more into the how to get accepted, how to be productive, how to get a job, how to get fundings. Because now the big thing in academia is to bring funding. And we all know that research funding is not much. And so it's a zero-sum game.
Especially if you're doing cultural studies.
Yes, especially if you're doing arts and humanities and cultural studies and, other things. So, it's very often it's about learning to play that game that might get you successful. And I mean, I've seen the other side of the coin, some supervisors are better teaching you that than others. But ultimately, I think it comes down to two aspects. One is the policing of disciplines borders, and the other one is this marketization of the academia. So there are few jobs now. And knowledge, yes. So there are few jobs, and knowledge means to be productive. And to be productive, you need to appeal certain communities, be accepted in certain journals. Produce as many papers as you can. Sometimes privilege quantity over quality. Get funding and get a job, and then a better job and a promotion and whatever tenure or But the other thing is about how disciplines tend to police their own boundaries anyway. So if you try to ask questions that are not in the realm of a certain discipline, that means upsetting a lot of people. And so it can be the reason why, for example, you don't become a star academic, because you are asking the wrong questions, or you're asking too many questions, So I guess, again, from I hate to say that, but it's a deconstructive point of view.
It's a point of opacity.
It's unavoidable. It's unavoidable that disciplines try to police their boundaries, right? The discipline wants to be specific, wants to know what it is about, what are the allowed methodologies, and what is the way you do research in this field. Yeah. And so there is always a certain policing, a certain violence. It's Derrida's term, violence in how you constitute knowledge, because you have to sort of cut out certain people and impose a certain canon and a certain methodology and a certain knowledge on people. But at the same time, these borders, we know knowledge very often develops precisely when these boundaries are transgressed. And I'm not just saying, by doing interdisciplinary work, but simply by asking questions that they're not usually asked. So you're right. I agree with you that we should much freer to ask, questions like what works for me? What is good research for me? What is even that it's going to upset communities that might decide on my future, but yeah.
That's interesting what you bring up about borders. I hadn't thought about that. Yeah.
Yeah.
So let me ask two last questions. We'll go to really light, quick questions, and that will be the end.
Okay.
Wait a minute. I lost the question.
I lost the question. Oh my gosh.
Yes, found it. Okay, so maybe you can tell us a little bit on that. You were working in the industry. I'm guessing it sounds like you were having a good time. Why did you choose academia? And I know that you said that, okay, partly it was you want to do a PhD because you thought you wanted to get more knowledge. So that makes sense. But on a grander scale, why did you move from industry to academia?
I wonder every day about that. Why did I do that?
Especially when the paper slip comes, right? The payment slip.
Yeah. Well, yes. I mean, I guess that was, yes. It was getting knowledge, and it was also, I guess, it's very misplaced. But I wanted to do something more, feel more useful, give back to the community, or however you phrase it. For me, it was also a political move, right?
I see. Yeah.
I just didn't want to work to just help a company make profit. And then here I am, and the university is marketized, is liberalized, and everything that counts is, making money, extracting money out of students, or whatever. So why did I do it?
Oh my God, I can't believe you mentioned that. That's so true. Extracting money out of students. Oh my God.
Yeah.
That's so accurate.
Yeah. And very often, there are cuts, and you try to make things work, but student experience is not so great. And they're paying a lot anyway. So anyway, let's say that from a personal fulfillment point of view, it made a lot of sense. But financially, for example, not much. Yeah.
Yeah. And last general question, can you tell us a little bit about your current research interests, kind of like...
Yeah, so very briefly, I'm working on AI now. Well, who isn't? But I'm interested in this idea of both a deconstructive but also conjunctural reading of AI. So why we have this particular kind of AI, as I was mentioning, it has to do a lot with political circumstances and social circumstances and the general balance of powers in the world, I guess. But so I'm wondering if it's possible to have a conjunctural analysis of AI, if it makes sense. So I've been writing already a bit on AI. So I published a few papers with my co-author Eleanor Drage, which, by the way, is another person in Cambridge. And I don't know if that's but she's incredibly good, and she's actually the lead author in some of those papers. But we've been working on AI as a performative system. So the idea that it's a socio-technical performative construct, and it's the biasing AI is not the solution at all, because if it's then deployed in some context, deployed by someone who is biased and is using it in a biased way, or the society is biased. In order to debias AI, you should debias society. And it's the whole idea of making AI more human. Why? Because it isn't human enough. It has the same prejudices we have. It has the same biases we have. It's racist. It's xenophobic. It's so we're looking at the performative aspects of AI, and we're using feminist theories like Karen Baratz and Judith Butler's to analyze this performativity. So I think I want to go on in this way. The conjunctural analysis means that we look at the specificities of the context.
That's interesting. I should read some of these papers. Okay, so final section. 5 quick questions, okay? Quick questions, quick answers.
Okay.
So, favorite place to live?
London.
Interesting. So it's not in Italy.
So it's so expensive. That's a problem. London, as it was back in the 90s, maybe, or in the early 2000s. Yeah, it's not London anymore, but it's still my favorite place, or one of my favorite places. So yes.
Number 2, for someone to be, so that is like fill in the blank. So for someone to be my friend, they have to?
They just need to be politically engaged.
Interesting.
Yeah. Like, kind of having some passion in life.
Yeah. Number 3. If you had to choose a different career, what would it be?
Well, I've gone through 3 careers now. Right. A different career, selling ice cream on a beach.
Oh.
In the Caribbean or something.
Oh, that's cute. Number 4, I think this is. Are you a night or a morning person?
I am a night person.
Me too.
Yeah.
And number 5, the 3 books that have influenced you the most.
Oh gosh. Oh my god. Oh my god. Oh my god. I'm drawing a blank here.
That's hard, right?
Ah.
I think we'll become a podcast theme. I asked that to William, and it was also hard for him. I think I should ask everybody. I feel like it's an interesting question.
But it shouldn't be, please, academic books, right? Can it
No,
be anything?
any kind of books. Any kind of
Okay,
books.
so everything written by Alice Smith.
Oh.
Alice Smith is a British writer.
Okay.
She's amazing. Let's say also maybe Marguerite Duras. She's a French writer.
Okay.
I know. She wrote L'Amant, The Lover. There are so many. Changed My Life Forever. I think it was Stuart Hall wrote. Stuart Hall, as in, the guy from Cultural Studies. That's not very satisfactory, is it? I didn't say, I don't know, Joyce's Ulysses or...
No, I don't think it has to be. I mean, for me, one of them is When Nietzsche Wept. It's a novel by Irving
what's
Yalom.
that?
Yeah.
Okay, worth checking, maybe.
I think so. I think it's an incredible novel. I think actually giving a list that doesn't have stuff like Joyce's Ulysses or something is good, because then we learn about... Otherwise, it's just too mainstream, right? Like, I don't know the authors you mentioned, so it's good. Now I'll have something new to check out. Okay. All right, cool. Thank you very much, Federica, for being here. I think this was a very, very interesting discussion. Hopefully it helped people get into the book. And thank you very much for being here. And of course, folks, everybody, I mean, you'll see all the relevant information down in the video description, and you can find ways to contact Federica, where to find the book, and any other references we made throughout our discussion. Last words?
Thank you very much. Thank you very much for inviting me. Thank you. Appreciate it. Thank you.
Cool. All right. Bye-bye, everybody.